1,000. So that's 1,165, master serial number, bombs for Josh 435, poi 22. So we're making a game engine based on this old game I made over 10 years ago, which is basically a side-scroller Bomberman that uses proximity mines rather than Bomberman bombs. And we're going to take this, which was made in Flixel and Flash, and we're going to make it in our own game engine. So this is the game engine, and we don't have time to review everything in it. But this is the basic idea, right? We got the black areas are void space, the white areas are tile space, and there's other things, but we don't have time to talk about this because we're on a code review. Here is what the side project point sprite. Oh my god! Here is what the side project point sprite renderer currently looks like. Let's go review the code. So first of all, Atomic Ivy MMO.js, our main game engine. We've updated the source code snapshot. So if you want the source code for the video that you're watching right now, github.com/kanjicoder/aim_1165. This line of code has been changed, therefore this delta marker has been updated. Down here, we've added some tags to find some things. So in this GPU data function section, which is the GPU data subsystems functions section, we're going to have all of the function GPU data. Every single function inside this section is going to start with F for function and then GPU data, and then what kind of GPU data function it is. Because we're programming in a C99 style where we try to avoid, and for three times, avoid object-oriented programming. We're doing data-oriented design. Why can I not pronounce that? I always fucking started that. Data-oriented design. Data-oriented design. Yeah, I don't know why. My brain's fucked up, I guess. Data-oriented design. Okay, so inside of GPU data init, I think we added like a tag to find a piece of code that I was interested in. Yeah, right here. Here's where we create the texture, right? So we tell WebGL to allocate a texture in GPU memory, or I guess reserve a texture slot, I guess, in GPU memory. And we get a texture handle right here. We get this texture handle back. Now, in WebGL, this is actually an object, but if this were OpenGL, instead of create texture, it's like GL gen texture or something like that instead. And then what comes back is actually an integer texture handle rather than some weird ass WebGL object. But hey, it's WebGL, so it's not completely analogous. Like OpenGL and WebGL aren't completely analogous, but they are very close. And right here we have a little tag WGL create texture, right? Or create, right? This is just a unique string to help me find this piece of code in the future. So you're going to see this string in my footnotes later. Let's go down to the next section. So right down here is our previous notes from the previous video. And then if we go down here, we have the notes for this video. So video 1165, that matches this. And no changes in this file because the new code is going into point sprite renderer version 22.html in the point sprite folder within research and development, within documentation, within the root repo known as AIM, AIM standing for Atomic Ivy MMO. Now we did add a whole bunch of notes up here. Now I usually don't like review all these notes, but since we didn't make many changes in here, we can highlight these and look at these really quick. So all we're doing here is making kind of like a poor man's Google search. How to upload texture memory. If I type any of these phrases, it could bring me to this section. And then what I need to type in order to get to where we needed to go is I need to type this phrase, STPMB, with only single underscores. And the reason I typed it this way is because I've already made a poor man's Google search in a previous video where I typed it this way with one underscore, and that will actually bring you to the code of interest over here, this text sub image 2D for uploading texture memory to the GPU. Also, I've made how to generate a texture, so if I type any of these phrases, it'll bring me to this block of commentary, and then the C tag. So tag is, it's like a filter, right? We're taking all these possible things I could type and tagging them, and then we want that filter to filter down to this one thing, WGL create texture. So if I type any of these things here, then the line of code that I'm looking for is tagged with WGL create text, right? And if we go over here, that's the line of code I was interested in. If I type any of those things, this is what I was looking for, right? Okay, so now that I've done that, we already talked about this. Let's actually go look at poi22.html, which is the file responsible for what we're seeing here. This is two draw calls, one for the mock tile map, and then one for our 3 sprites that are moving upward on screen. So if we go over here to poi22.htm, let's go over the changes. Inside of the globals section, if we scroll all the way down to the bottom of our globals, so let's highlight this as well. In the bottom of our globals, we have a new global variable, data, global data, P2K for pixels 2000K, 2000K being like 1,000, you know, like when people are talking big numbers and they're all like, yeah, I went to the casino and I put down 2000K on the craps table because I'm so filthy rich I can just throw away my money, right? Yeah, pixels P2K, right? P2K means the exact same thing as Pix 2048 means, right? It means the exact same thing, but this is a 7 token expression of this meaning, and this is a 3 token expression. Or actually, no, that's not correct. That's not the correct thing to say, because this is actually a token, right? This is a token. So what I actually mean to say is this is a 7 ASCII character representation of this concept, and down here is a 3 ASCII letter, no, ASCII, I'm trying to be correct here, 3 ASCII character expression of this concept up here. So this variable represents the CPU side texture, and then this variable right down here represents the GPU side texture, but this is the CPU side texture handle to the GPU side texture, the GPU side version of this CPU side texture over here. So this right here, this texture handle, it's kind of like a receipt. Like whenever I want to tell WebGL to do something with my texture, I don't give them the texture, I give them a receipt to my texture and I tell them to do something with it. So for example, it's like, let's say you're at the coat check, right? And I've made this analogy before, but let's say that you have a pen in your pocket and you don't want it to get wrecked or something. So you give the coat check lady your pen, and you're like, hey, here's my coat check ticket. Could you go put this pen into my coat, right? And so they take the ticket, which is not your actual coat, and they take your pen, which in this case would represent the bitmap data that you want to upload, and they go find your coat using that ticket, and they put the pen in that coat. And that coat would be like the actual allocated texture memory, the texture slot on the GPU side. And I use I was gonna say GPU lady. I use coat check lady because the coat check lady is a lady at the bar I go to. So in case you're wondering why I chose a certain gender, it's because that's my goddamn life experience. Leave me the fuck alone. Okay, so in setup right here, let's scroll all the way. We're gonna scroll all the way down in setup because the new code for uploading our texture memory is all the way at the bottom, at the very bottom. So you see all these lines that are highlighted, and you can see that this is the bottom of the setup section. Okay, let's go look at this. Alloc GPU texture, that stands for allocate GPU texture. If we grab onto this and Control F, we have more supplemental information about everything we're doing at the bottom of the file, as we try to do for every section of code we create. And first thing we're gonna do is we're gonna get that texture handle. So the code check analogy doesn't really hold up perfectly because if we keep to the code check analogy, then you walk into the bar without a coat and you tell the coat check lady, hey, could you make me a coat and then hang it up back there? And then you give the coat check lady some money, which is like the create texture command, right? Or these are the orders you give the coat check lady, but you also have to give her money, so the analogy doesn't quite hold up. But then she goes back there, she sews a coat, and then she hangs it up somewhere. And it's like, it's the bare bones coat. Like, it's a bare bones coat, right? It doesn't have any features or anything. It's like the, I don't know, it's a coat template. You say she allocates you like some type of weird ass coat template, right? And then she gives you a coat check ticket to this coat template, but you have to come back periodically and tell her to do modifications to your coat, right? But you never get to see your coat. But you have a coat, but you never get to see it, and you get to tell her what to do with it as long as you have this texture handle to hand to her every time you tell her to do something with your coat. Yeah, that analogy gets really convoluted once you try to like make it connect. But anyways, so here is our global data, Pix 2000K texture handle, right? And we use the WebGL context.createTexture to create this texture handle. Okay, so now we're going to do WebGL.bindTexture. And what we're doing here is we are setting this specific texture in focus and also giving it a use case. So here we're saying, we're basically handing the coat check lady our ticket and saying, hey, you know that coat, the type of coat that is, it's a raincoat. It's a raincoat, right? So texture 2D. The type of the texture is a two-dimensional texture. So we're binding the texture. But not only are we saying that's the type of texture, but now that texture slot is in focus. So any future commands that have to do with a texture 2D are going to apply to your code. So if you leave and some rando comes by and says, hey, could you put polka dots on the coat? The coat? Well, the last bind texture was for your texture handle with your texture receipt. So if some rando comes by and says, hey, could you put polka dots on the coat? Well, the coat is going to be your coat. So some rando comes by, says, put polka dots on the coat, and now you got polka dots on the coat, right? So bind texture also has to do with what coat or texture WebGL, aka the coat lady, is currently obsessed with. Okay, yeah, this analogy, maybe I should have made this analogy, because this analogy is, I don't know, man. Okay, so anyways, a warning here. If you're using WebGL 1, you would probably be using text storage 2D for some things we're doing, but unfortunately, we can't really configure in one step and then upload in another step. Well, we can, but it's a waste of fucking typing. We do not have access to this command in WebGL 2 context. We can't use this command. So instead, we're using text image 2D. And the thing with text image 2D is that to configure the texture, we would do all of these commands and we would just leave this slot null. But it's like, come on, we already did all this fucking work to configure it, and all we have to do now is just supply the goddamn texture. Might as well just supply the goddamn texture and upload it, right? Now, if you put null in here, what it's going to do is it's just going to take the current texture handle in focus, and it's going to assume that all this configuration applies to that texture handle that is in focus because of bind texture right here, this texture handle right here that was created up here. So we already created our CPU side texture right here in the previous block, the init CPU texture section. So since we already have this texture right here and we've already put stuff in it, we might as well not just set this thing down here to null, right? We already got the texture, throw it in there. Now this is the CPU side texture. Now the reason it says array buffer view here is because the type of a uint8 array in JavaScript, I don't know if you call it the subtype or the base type, but uint8 array extends array buffer view. And the type of this parameter right here is an array buffer view. So this is just a reminder to me to do that. Okay, so other things to remember here. So it's a two-dimensional texture. The level of detail is 0. So MIP map level 0 is what this means. So we're not doing MIP mapping. Therefore, we're using a full resolution texture. RGBA 8 UI means that it's a texture where the bytes are stored red, green, blue, and then alpha bytes. There's 8 bits per byte, and the bytes are unsigned integers. This is the CPU side data format. The texture is 2048 by 2048. That applies both to the CPU side and the GPU side. Border is always 0. I don't know what the fuck this is used for, but I've never used it. Now, for the GPU side format, the G format that's tagged right here, we actually need 2 symbolic constants. We need RGBA integer and unsigned byte. And the combination of these 2 constants must be compatible with the constant that's used up here. And it took me a really long time to figure out the correct combination of this and this, a lot of trial and error. But now I have the correct combination, and I've been using it for years, and it fucking works, so I stick to it. And here's the texture we're uploading, and that's the end of setup. Then down here, we have a whole bunch of footnotes for what we did in this video, and we're out of fucking time. My name's Kanji Coder. I'm making a game engine. Like, subscribe, follow.